Not every server should face the open internet. A bastion host, also called a jump host or jump box, is a hardened SSH server that stands as the single controlled gateway into your private network, protecting every server behind it. Here's the problem. A developer on a laptop tries to SSH directly into an internal database with the command SSH user at db.internal. The firewall slams the door shut, and for good reason. Exposing internal hosts to the public internet is a security nightmare. Attackers can scan for open ports, brute force credentials, and pivot through any vulnerable service they find. The traditional solution is ProxyCommand. You configure your SSH client to route through a bastion using the line ProxyCommand SSH, W%H, %P bastion. The placeholders %H and %P are automatically substituted with the target host name and port. OpenSSH expands them at connection time, so you never edit the config per destination. OpenSSH 7.3 introduced a far simpler option, ProxyJump invoked with the J flag. The command SSH bastion internal does the same job in one line. OpenSSH transparently wraps ProxyCommand under the hood. You write less, read more, and stop worrying about placeholder syntax. Sometimes one bastion isn't enough. Chained hops let you tunnel laptop to bastion 1 to bastion 2, and bastion 2 to the final internal host. This works through ProxyCommand's netcat mode, where each hop forwards standard input and output like a relay race. TCP stream in one end, TCP stream out the other. In the cloud, bastion hosts shine. Inside an AWS VPC, your private subnet holds databases and app servers with 0 exposed ports to the internet. The bastion is the single audit point. Every SSH session is logged, every key is centrally managed, and key-only authentication enforces hardware-backed identity. You get defense in depth, a clean audit trail, and dramatically reduced attack surface. The file /ssh/config is the OpenSSH client's cheat sheet. Every host block names an alias you can type instead of a full address, and the directives inside that block set the rules for every connection that matches. ProxyCommand is the classic way to jump through a bastion. The line ProxyCommand SSHQ, W%H, %P jump.example.com tells the local client to launch an SSH session to the jump host, and the W flag turns that session into a STIN-ANST tunnel aimed at the real target's host and port. The tokens %H and %P are auto-replaced with the resolved hostname and port, making the directive reusable across any alias. ProxyJump is the modern shorthand that wraps the same behavior into a single directive. ProxyJump user at bastion does exactly what ProxyCommand did, but without the manual, W plumbing. The same logic is available on the command line as the J flag, and you can chain multiple hops with commas, like J user at bastion 1, user at bastion 2, letting SSH tunnel through every bastion in sequence before the final connection lands. The connection flow happens in 3 clean stages. First, your local machine opens an SSH tunnel to the bastion. Second, the bastion opens a fresh TCP connection from inside the private network to the target host. Third, both sides relay bytes back and forth through the bastion. The target never sees your laptop's IP, only the bastion's. That indirection is what makes the architecture safe. Security wins stack up fast with this design. Only the bastion's port 22 is exposed to the internet, so your internal hosts can sit safely in a private network with no inbound access at all. Every operator authenticates through one hardened choke point, which is where you enforce MFA, and when keys need rotating, you change them in one place rather than chasing credentials across dozens of machines. Before we make or troubleshoot SSH connections, it's worth knowing exactly where the configuration lives and which OpenSSH version is in play. In this short demo, we'll parse the active SSH config, list the /.ssh directory, confirm the installed OpenSSH release, and pull the ProxyCommand entry straight from the man page. We start by clearing the terminal, so we have a clean canvas for the rest of the demo. The clear command wipes the visible scrollback, but leaves the shell, environment, and history untouched. The first real step is reading the active SSH client config. Running cat /.ssh/config prints the file the OpenSSH client consults whenever it resolves a host name, so you can see exactly which hosts, users, ports, and options are actually in effect. Next, we list the /.ssh directory itself, so we can see the keys, known _hosts, and any other files the SSH client relies on. File permissions matter here. Anything too open will cause OpenSSH to silently refuse to use the key. Now we confirm the OpenSSH client version with SSHV. Note this flag is a capital V, and the version string is printed to stare, meaning it shows up even though the command exits successfully with no stout. Finally, we look up what ProxyCommand actually does by grepping its entry in the SSH_config man page. The I flag makes the match case insensitive, and A1 also prints the line that follows the match so we get the full description, not just the heading.